Hello friends, so welcome back to the third lecture of center of mass. So today class we are going to discuss about how to find the center of mass of a half disk and hollow hemisphere. So first we will start with half disk. So here center of mass of half disk. So in the last class we already find out the center of mass of a semicircular ring. So here what will I take? I will take half disk of radius r, correct? So here half disk of radius r, and let us consider m is the mass of this disk. M is what? Mass of disk. This half disk mass is what? M. Now if you will focus, you will find that this disk, this half disk is made up of what? Small half ring. If you will divide small half ring and you will add it, you will find it will give what? One half disk. So here what will I do? Here I will take one elemental ring on this disk. I just consider elemental ring. Elemental means as I will divide this whole disk in small part. That small part means what? That small strip I will take, that is what? Elemental part of this whole disk, that is in the form of what? Ring. So that's why I will take here, it is what? Elemental ring. So let us consider this elemental ring having radius what? Y. If this is the y, let us take this thickness of this ring is what? This thickness is what? Dy, correct? Now because the total mass is m, so this is what? Small part of this half disk, so its mass will be dm. Okay, so now I have to find, my main objective is to find what? Center of mass. So here you can see that along x, if I will keep my hand, so right and left is symmetrical, so x center of mass will be at origin, so x center of mass will be here only. But if I will keep my hand along y center of mass, you can see it is not at origin. Why? Because it is not symmetrical here. Here up and down is not same, so we have to find y center of mass. Our objective is to find the coordinate of center of mass in y. Okay, so y center of mass formula, we have y center of mass we can find by using this formula, integration of what? dmy divided by integration of what? dm. Now this integration of dm is what? Dm is what? The elemental part of it, that mass is dm. It means this mass, this elemental part mass is what? dm, correct? This mass is what? dm. Okay, like that, if small elemental part I will add, I will get total mass is what? m. So if you will integrate dm, you will get m, so it can be written as 1 by m, because total mass is what? m, we already took it. So 1 by m integration of what? dmy. Now first we should find what is the dm. Dm mass, that means this elemental part mass, this elemental ring mass. So we can find it, dm value. So here you can see this total mass is m, this half disk mass is what? M, and this mass is uniformly distributed over its area. What is the area of this half disk? Because complete disk area is pi r square, so half disk area will be pi r square by 2. So mass per unit area will be capital M divided by pi r square by 2. This is what? Mass per unit area. Now I have to find only mass on this area, this is strip area. So how can I find the area of this strip? So length of this strip is what? Pi y, because total length of the ring is what? 2 pi r. So here radius is y, and we have not to take the total length of the ring, it is a half ring, so it will be pi y only. So pi y length, and thickness of this is what? dy, so it will be pi y dy. This is what? D area of what? This elemental part. So now you can cancel this m pi, this 2 will go up, so it can be written as 2m by r square y dy. This is nothing but the dm. Dm is what? Mass of this elemental ring, correct? Now here, what is this y? This y is the coordinate of this elemental ring, coordinate of this elemental ring. That means the center of mass of this elemental ring, y coordinate, This y is nothing but the y coordinate of center of mass of this elemental ring. So already we studied in last class that y coordinate of center of mass of a half ring is what? 2r by pi. So here radius is y. So this y is nothing but the 2y by pi. So do not confuse with this. You can write it as 1 by m integration of dm value is this one, 2m by r square and y dy. Here this y is not this y. This y is what? Center of mass. Y coordinate of center of mass, this half ring. So that's why we will write this was as what? 2y by pi. Correct? So here it is better to write ycm. Okay. ycm. Okay. Here if I will write, you will not confuse. So it will be what? 2y by pi. So now what will I do? Here m and m will cancel out. Anything we can cancel? No. So 2 into 2, 4. 4 by r square, 4. Okay. And r square, pi will take outside. Okay. We can take outside pi. Yes. So pi r square. Inside will be y dy. So we took already everything now. 2 to 4. Correct. R square pi, and this y will multiplied. So it will be y square dy. Correct. And you know the y is changing from 0 to r, so we will integrate it from 0 to r. Correct. So here it can be written as 4 by pi r square into y cube by 3. So after integration you will get r cube by 3. It will be what? Y cube by 3. Upper limit is what? R. Lower limit is 0. So finally you can write it as a, here you can write 4 by pi r square into what? When you will put the limits, it will be r cube by 3. Okay. So this r square will cancel out this. So finally we can write it as a 4r by 3 pi. It means if you will take a disk of radius r, its center of mass will lie at this point. The distance from this origin will be 4r by 3 pi. Correct? Okay.